Geometry Crescendo, Topic 3, Compositions of Transformations. Level B. Take the next 20 seconds to read this problem and understand what it's asking you to do. Go. This problem is asking me to come up with a sequence of similarity transformations that's going to show that triangle XYZ is similar to triangle UVZ. This problem has actually given me a similarity statement. It just doesn't look like it. So let's write it in notation that's more familiar to us. Triangle XYZ is similar to triangle UVZ. The Regents was really kind to us on this question. They already annotated the diagram with some congruence marks here, so I know that angle Z is going to be congruent to angle Z. That lines up with my similarity statement. I also know that X is going to correspond to U, which also lines up in my similarity statement. So anytime I'm describing a series of transformations, I know I'm talking about rotations, reflections, translations, and dilations. In this case, because I am looking for a sequence of similarity transformations, I know that this is going to involve a dilation as well as some other combination of transformations. We have to dilate here because dilations are the only transformation that we have that will create figures that are similar rather than congruent. So when I look at this shape, I know first that I need to move this angle X over to map on to angle U. So in order to be able to do that, I'm going to have to turn this shape. I'm going to draw an intermediate shape on my paper. This is just going to help me keep track of my vertices. So I am going to turn triangle XYZ about point Z until this line segment XZ lands on top of ZU. I need to get X over towards the same position as U. So if I just turn my figure, I will end up with X over here in the same position as U, and then I'll end up with Y over in the same position as V. Notice I didn't use any prime notation here, and I'm doing this in pencil. That's because this is just a step along the way. We haven't actually finished a transformation. We're just on track to getting to our transformation. So our answer needs to follow a specific form in order to ensure that it earns full points. So I need to be really clear about what transformation I'm doing to this shape. So we're always going to follow the same form. We're going to start off by saying what the transformation was and which figure we did it to. So we rotated triangle XYZ, and we have to give a center of rotation. We don't often have to do this in the coordinate plane because we're rotating about the origin, but now we're not rotating about the origin, we're off the coordinate plane, so we're going to rotate about point Z because both triangles use point Z. Your next impulse might be to say 90 degrees or 180 degrees. We actually aren't going to list a number of degrees this time because we don't have a grid to guide us. We're just going to use the segment lengths as our directional markers here. So we're going to rotate XYZ about point Z until XZ maps onto UZ. So what I'm telling this shape to do is turn until your line segment XZ is in line with UZ. That's how I'm telling my shape that it should stop moving. From there, I know I'm not not done yet because I actually haven't performed that dilation that I knew I was going to have to perform. I also can see that my pre-image has not fully mapped onto my image. So after I rotate XYZ about point Z until XZ maps onto UZ, I'm then going to dilate triangle XYZ so that I can make it larger and have my vertices line up. Again, I need to provide a center of dilation. So I will dilate XYZ about point Z, that's that shared point. And just like I didn't give a number of degrees for the rotation, I'm not going to give a scale factor for the dilation. I'm just going to say how much I want to dilate it by telling the figure when to stop dilating. So I'm going to dilate XYZ about point Z until triangle XYZ maps onto triangle UVZ. By listing out the two triangles that ultimately need to map out onto each other, I'm saying you can stop dilating this figure when this shape maps on to this shape.